Hi guys, so today we'll be doing the lock boxes task. This task is just a one task and it talks about working with sets, stack, and some basic Python functions, lists, and data types. Okay, so basically, let me just go through the question and let's see how or what the task entail. It says that you have n numbers of locked boxes, right? So you have a particular number of boxes that are locked in front of you. Each box is numbered sequentially. That is, we have it box one, box two, box three. But now it starts from zero, so we're gonna have box two n minus one. So if we have seven boxes, it's going to start from zero, one, two, three, four, five, six. Okay, and each box may contain keys to the other box. So if you open a box, it can contain keys to some other boxes. Okay. Um, okay, let's see. So we are given a prototype to use to check the boxes and see if we can unlock all boxes based on the keys inside the boxes that we have available. So boxes is a list of lists. So the boxes would be a list. As you can see, this is a list which contain lists, and then a key with the same number as a box open that box. A key with the same number as a box opens that box. So this key is meaning that okay, inside box zero we have one, meaning that it can open box one. There's a key here. So inside box two, box one, because this is box zero, this box one we can open two. Inside box two we can open inside box one we can open two. Inside box two we can open three. Inside box three we can open four. Okay, so this one, if we check it, if we check this box, you can see that it's openable and then we return true. For this one, we have how many boxes? One, two, three, four, five, six, seven, which is 0 to 6. So if we open the first box, we see that we can open one. This one is automatically open at first. The first box is always open. So we can open one and four and six, right? One, four, six. So because we can open one, so it give us access to this one. And then when we have access to this one, it means we can open two. So we have one, two, four, six that we can open now, right? So since we can open two, we go to the next one. So we have 0, 1, 2, 4, 6. I think so far we are left with 5 and 3, right? So can we open this 0, 1, 2, 3? Can we open, let's see, 0, 1, 2, 3? So far, can we open this one? So 0, 1, 2, 3. So we can open box 0, 4, 6, 2, 0, 4, 1. Okay, good. So we can't open this one yet, right? Because we don't have box 3 key. So let's see, but we have box 4, right? Key inside. So we'll go to box 4 and box 4 has box 3. So it give us access to open this box 3. So by that time we have this one and then box 4 contains this. So at the end of the day, we would have opened all boxes. For this one, it will return false because this is the first box, 1 and 4, right? So it give us access to this one and the fourth one, 2, 3, 4, and the fourth one is empty. So we have access to only these two so far. So and box 4 is empty, right? And then we have access to box 1. So box 1 is 2. So we have access to this one as well. So far we have 1, 0, 1, 2, but we don't have access to 3. And is there any way we can open 3? No. Box 4 is empty, so there's no key again. Box 2 is this one, so you can only open these ones. And then so far we cannot open box 3 and we cannot open box 6, right? 0, 1, 2, 3, 4, 5, 6. So this one will return false. Okay, so I've created the test file and this one is empty, so we write our code to and then probably I'll just explain as we go on. So the first one is we have to open the the file, right? Our shebang user binary and then Python 3, give it a description and say a method that that determines if all boxes can be opened. Okay, so let me just copy this one. Anyway, so we'll define our prototype because we are not importing anything. All right, so can unlock all, and then where boxes. So this one too, let me just paste this here. Okay, good. So I think we're good this way. So fine. So the first thing we're going to do is we need to know how many boxes we've unlocked. So we'll create a set unlocked, and sets are saved in curly braces like this. The first one is always unlocked automatically, so we'll give it 0. Okay, so the first box is always unlocked, so it's going to have 0 because it's already unlocked, right? And then we need to take track of the present box in front of us, and then we can access the item inside those boxes. That's the list. So we'll call that a stack, and then we give it the okay. um the first one will still be 0 because that's box 0 is what we have access to, right? So the first box is unlocked, so the first box is unlocked and it's the present one we are viewing, right? You can access, assume all keys will be positive integers. They can be keys that do not have boxes, and then a key with the same number as a box opens that box. Okay, return true if all boxes can be opened. Okay, I think we are almost done here. So what we'll do then is, am I here? What's going on? Okay, so what we'll then do is we would say okay, while we have something in the stack, that is while there's a box in front of us, right? So what we'll be doing is this stack, right, would, once we visited this box, we'll remove it from the stack. Okay, so it's going to be like a LIFO, right? First in, last in, first out, or something like that, or a queue. I think a queue is what we're gonna do. We're gonna queue first in, last out, right? Yeah, I think something like that. Yeah, so that's what we want to do here. So while stack, so we'll say while stack, and then so it's, we're going to find a way to be popping out this item, okay, after it has been visited. So for now we are visiting it, and then once we finish visiting it, we pop it out, and in this place we have to have find a way to append. If we visit this guy and there's a key, for example, we visit this one and there's a key, so we'll have add that key to this place. So the stack will now be the next guy, and anyone that gets unlocked will be appended here. So what we'll then do is we'll say so we'll say the current box, right? The current box is equals to, so what is our current box? We need to know what our current box is. The current box will let me stack dot pop, because the pop would remove that item from the stack, right, and then return that item. Okay, so by the time it's returning that item, it's being saved inside current box. Okay, so since it's saved inside current box, we can use it and iterate over it. Okay, so we then say for key in, we have the boxes, right, at index current box. So if the current box is 0, so we have boxes at index 0, which would be this, and then so this one is key, not kit. so for readability. Okay. So basically that's it, and then yes, so this one would loop through each item of the list, because the list could contain one or more, zero or more stuff. So if it's zero, it's not going to probably run. Okay, so we then say if, or yeah, let's just say if the key, okay, we want to see if the item here, if this one is one, right? This one is one. We want to see if the key is less than, we have to make sure it is less than the length of the boxes. Because if this one is 14, it cannot open any key here. So we have to make sure that it is within that range, right? Between 0 to um, um, between 1 to probably the last item of the box. Okay, so we check that, and then if the key is not in, if the key is not in unlocked, we have to make sure that we've not unlocked that key. Since unlock is going to just save unique items, so it's going to make it easier. Okay, so for example, if we meet, if the key is zero already and it's not, is zero is already here, so we don't need to do anything, right? So if it is not any of these things, it's less than, so it means it's within this range and we've not unlocked it before. That is when this one should run. So we'll come here, and then what should we do? Then if it is not there, then we will say okay, it has been unlocked. They will add it to unlock keys. So the sets have this dot add, and then we'll say the keys, so it will add that, and then the stack, remember the stack, this zero is popped up already, so we need to add that box, right, currently in the stack. So we just say stack for list, we have dot append, so we say stack dot append, and then we say key. Okay, so stack dot append key, and that should work. So that would iterate over everything, and then once it's done, we get out of this loop, and then it goes back to this while stack, and then start again till the end. So once we are done with everything, we want to then return. This is where the logic is, and you say the length of the unlocked. We want to see if the length of the unlocked is the same as the length of the boxes. So if it is the same, it means that they are equal, which meaning that all the boxes have been unlocked. Okay, so I think that's all for now. So let us test our code and see if it works. Why is this taking time to load? Should I? Okay, so if key is not, and key is not in unlocked, is, and key not in unlocked, not is not in unlocked, key not in unlocked. So let us rerun it. Okay, so what do we have? Unlocked. Yeah, sorry, I think I gave it a wrong name. So, yeah, it is unclocked here, so it is unlocked. So let me clean the screen and run it. So we have true false, and let us use bytecode style on our code, and then yes, it's good. So we could add it connects and say unlock boxes. So, and after that, we'll check our code to see we are correct. So this is past seconded one already. So let me allow it push first. Okay, I think my network disconnected, so I have to reconnect and then push. So I think I'm back and with push again. Okay, it has pushed and let's check our code. Okay, it's worked and that's it. See you in the next one.